Page 464, number 21, we're asked to find a unit vector in the direction of the given vector. So vector u is given in component form as -2, 4. So I'm going to write my answer as a linear combination using the standard unit vectors I and j, where I is in the x direction and j is in the y direction. So the first thing we need to make it a unit vector is for it to have a magnitude of 1. So we need to find the initial magnitude of the vector. So that's our first step. So the magnitude of u is going to equal the square root of 2 squared plus 4 squared, which is going to give us the square root of 20, and we're going to simplify that. So our unit vector length, I'm sorry, it's not our unit vector yet. Our vector u's length, its magnitude, is 2 square root of 5. Now we're going to use that by dividing our vector by that length to turn it into a magnitude of 1. So in other words, u is going to end up as a unit vector in this way. So we're going to take 1 over the magnitude of u times u so that we can create a unit length vector. So that's going to be 1 over 2 times the square root of 5 times our vector, which is -2, 4. So we're going to get, this now becomes a scalar, and we're going to multiply that times each component and then write it in terms of I and j. So let's first distribute that scalar, and we're going to get -1 over the square root of 5, because our 2's will cancel. Let's put our vector notation around that. And then our other component is going to be 2 over the square root of 5, because we're going to multiply the 4 times 1 over the square root of 2 times the square root of 5. So from there now, we can write it as a unit vector in this way. So we have our x magnitude, x component, which is -1 over the square root of 5, times I, plus our y magnitude, our y component, 2 over the square root of 5 times j. So now we have our unit vector in the same direction as u.